Hello, I'm Caleb Reyes, and I'm in sixth grade, and I chose terrestrial real estate as my project. The first slide is about the Goldilocks zone, which is also known as the habitable zone. There is only one planet we know so far that is teeming with life, Earth. And on our planet, water is a critical ingredient for life as we know it. While astronomers still don't know whether there's life on other planets, they narrow the search for potentially habitable worlds using a handful of criteria. Because our blueprint for life is Earth, astronomers look for planets with Earth-like characteristics, like liquid water. But a celestial object can only orbit so close, like Mercury, or so far, like Pluto, from its star before water on its surface boils away or freezes. The Goldilocks zone, or habitable zone, is the range of distance with the right temperatures for water to remain liquid. Discoveries in the Goldilocks zone, like Earth-sized planet Kepler 186f, are what scientists hope will lead us to water, and one day life. In this presentation, you will only see planets that are found in the Goldilocks zone, from our solar system, called the solar system, and the TRAPPIST-1 system. Imagine a place with not one, not two, but 7 Earth-sized planets orbiting a single star. The TRAPPIST-1 system is regarded by some as the crown jewel of astronomy's efforts to find life in the Milky Way. Mars is a cold desert world. The average temperature on Mars is a minus 85 degrees Fahrenheit, way below freezing. It is half the size of Earth. Mars is sometimes called the red planet. It's red because of rusty iron in the ground. Like Earth, Mars has seasons, polar ice caps, volcanoes, canyons, and weather. It has a very thin atmosphere made mostly of carbon dioxide, nitrogen, and argon. Although people would not be able to breathe the air on Mars, people could still use a spacesuit with oxygen masks. You would need to have closed buildings and shelter, and have a good supply of oxygen tanks. There are signs of ancient floods on Mars, but now water mostly exists in icy dirt and thin clouds. On some Martian hillsides, there is evidence of liquid, salty water in the ground. Quick history. Mars has been known since ancient times because it can be seen without advanced telescopes. There was even a flying helicopter on Mars. Seriously. The Mars helicopter Ingenuity successfully tested power-controlled flight on another world for the first time. It hitched a ride to Mars on the Perseverance rover and worked with the rover to explore Mars. Ingenuity was designed as a tech demo, expected to fly no more than 5 times over 30 days. It ended its mission in early 2024, having completed 72 flights in just under 3 years. Thanks, Ingenuity. Several missions have orbited, landed on, or roved around on Mars. InSight, Maven, Mars Reconnaissance Orbiter, and many more. Mars is the only planet we have sent rovers to. They drive around Mars, taking pictures and measurements. Learn more about them and what they have discovered by clicking the pictures below. Terraforming Mars and even Venus may be possible, says a 4-decade veteran of NASA. In fact, the former director of the agency's planetary science division, says he is working on just such a plan that would employ a giant magnetic shield to help each of those planets to start terraforming themselves. TRAPPIST-1F. TRAPPIST-1F is a super-Earth exoplanet that orbits an M-type star. Its mass is 1.039 Earths. It takes 9.2 days to complete one orbit of its star and is 0.03849 AU from its star. Its discovery was announced in 2017. Because this planet is thought to be tidally locked to its star, meaning the same face of the planet is always pointed at the star, there would be a region called the terminator that perpetually divides day and night. If the night side is icy, the day side might give way to liquid water in the area where sufficient starlight hits the surface. According to simulations of magma ocean-atmosphere interaction, TRAPPIST-1F is likely to retain a fraction of primordial steam atmosphere during the initial stages of evolution, and therefore today is likely to possess a thick ocean covered by atmosphere rich in abiotic oxygen. A new study published today in the Planetary Science Journal shows that the TRAPPIST-1 planets have remarkably similar densities. That could mean they all contain about the same ratio of materials thought to compose most rocky planets like iron, oxygen, magnesium, and silicon. TRAPPIST-1e. TRAPPIST-1e is in the habitable zone, the area around the star where liquid water is most likely to be detected. This system was revealed by the transiting planets and planetal small telescope TRAPPIST and NASA's Spitzer Space Telescope. The planets are also excellent targets for NASA's James Webb Space Telescope. Take a planet-hopping excursion through the TRAPPIST-1 system. TRAPPIST-1e is among the best potentially habitable exoplanets discovered. TRAPPIST-1e is 40 light-years from Earth, which may seem a long period of time, but compared to other habitable planets, this is one of the closest we have discovered. TRAPPIST-1e is in the habitable zone of its star, so that means resources that can be found in Earth can possibly be found in this exoplanet, such as water, iron, magnesium, and silicon. TRAPPIST-1e is a terrestrial exoplanet that orbits an M-type star. Its mass is 0.692 Earths. It takes 6.1 days to complete one orbit of its star, 0.02925 AU. Its discovery was announced in 2017. Since such an atmosphere is not present, it raises the chances for the planet to have a more Earth-like atmosphere instead. However, no atmosphere has been detected, and it is still possible that the planet has no atmosphere at all. Additionally, no helium emission from TRAPPIST-1e was detected as of 2021. And these are the credits, and that's it.